Uniform circular motion is the special case in which an object is moving on a circle at a constant rate. In this type of motion, the time it takes for the object to complete one revolution, called the period, stays constant. You know that the change of an object's linear coordinates with time is the velocity, or more precisely, the linear velocity. Similarly, the change of an object's position angle with time is called the angular velocity. It is usually expressed in radians per second. Angular velocity is a vector. Its direction is that of an axis through the center of the circular path and perpendicular to the plane of the circle, the so-called rotational axis. The angular velocity vector can point up or down, and this pointing indicates the sense of rotation, counterclockwise or clockwise, respectively. Because the displacement and the position angle are related, we can derive a relationship between linear and angular velocity. We only have to derive the two parts of the equation with respect to time. We can also relate the angular velocity with the period, which is the time it takes to complete an angle of 2 pi radians. It is immediately seen from these equations that, in the case of uniform circular motion, not only the period, but also the angular and linear velocity stay constant. Let's now derive the equation of motion. We only have to integrate the expression for the definition of angular velocity, keeping in mind that the angular velocity is constant in this case. Compare the result with the equation for uniform linear motion.